So this video is going to teach you guys how to use a free online program called Geogebra. It's something I learned in my master's program and does a lot of really cool things, and is something, frankly, I wish I'd been exposed to earlier. So to get to this, you need to go to geogebra.org. As you can see right up here, I would suggest downloading it for your home computers, but any school computer or whatnot, you can just use a web applet program for it. So the home screen changes for whatever reason, but if you're going to download it, obviously click here. If you're just going to use the in a browser, click this picture here. Now, I don't have Java on this one, so I have to get to it from here. So it's kind of the same idea, but I'm just going to click on this web start thing. So however you need to get into Geogebra, do that. So however you get in, it's going to look something like this. Sometimes it takes a while to load. So on one side, you'll have a graph. On the other side, it'll kind of show all the different things you plug in. So I'd suggest dragging this over because you're not going to need all of that. A quick overview of the program here. If you go to View, you can put a grid on there. Go back to View, you can go to Spreadsheet. It basically combines Excel with an entire graphing program. So let's say you wanted to come in here, you want to plot the point 2, 3. And it'll plot that for you. Let's say you want to graph -2, -5. It'll plot that. So you want to do a line in between these. You click on one of the points, you come up here to one of these tools. You can do a line through 2 points. Select 2 points, select A, select A2, it'll put a line. You can do a segment between the 2 points and it'll cut that line out of there. You can do raised, you can do all kinds of stuff. Let's say you want to do a regular polygon. So select 2 points and enter number of vertices. So let's use the same 2 points. Let's say I want a hexagon. So it just created a regular hexagon there for me based on that side length there. You can do area of this thing. You can do angle, shapes, slopes, you know, ellipses, hyperbolas, parabolas, all kinds of stuff. You know, circles with center with a radius. So let's say circle with a center through a point. So circle with center, select center point. Let's call this the center. And let's say that's going to be point on the circle. And it'll do a circle for you there so you can look at all kinds of geometric properties from there. So a lot of really, really cool stuff. So let's say you want to do a perpendicular line. Let's say I want to do a line perpendicular to that point and that line. And it'll do that automatically for me. So let's say you come down here and you actually want that point right there. Let's go up to this one, intersect 2 objects. So I want this and I want this, and it'll make a point F. And then you can come up here, you can click on it, and it'll actually give you the coordinate for it, 10, -1, right up here with G. And you can turn things on and off. So I can turn the circle off, I can turn the line off, I can turn the polygon off. So it actually gave you the equation of the circle over here. Center at 2, -3, radius of 80. You can turn that off if you want. All right? So if you know anything about Excel, you can do all kinds of stuff in here, pictures, whatever. What we're going to use it for is help with this Meteor problem. So let's turn the spreadsheet off. Let's turn the grid off. We're not going to really need that. And let's turn all of these off over here. We don't need those. And then you can delete these points or just start a new one if you want. Okay, so we got a brand new thing here. Another neat thing it does, if you go down to the input at the bottom, let's say you want to graph 2/3 x -7. There's your line right there. Let's say you want to graph, you know, y -2 equals 3x -4. So you're going point slope here. So it was through, it'll automatically convert it here into standard form for you. Okay, so now what we can do, let's say you want to graph, y equals 1/2 x. You got to use the caret to get a squared minus 6x plus 19. Okay, there's a parabola there. So you can come up here to the move, and you can just drag it and you can move this. You can click on the zoom in, and it'll zoom in for you. Click on the zoom out, and it'll make this thing smaller. So again, we could intersect all of these. We could actually shade some stuff in. We could find the area between these, different points, whatever. So how's that going to help you guys with the Meteor problem? Well, let's turn all of these off. So Earth is a circle, like I gave you. So I'm just going to make up something different. I don't want to give you the exact same numbers. So let's do that. Okay, x squared plus y squared equals 100. So there's a perfect circle right there. Now let's say I want to graph let's say an ellipse around it. Let's say it's an ellipse that I haven't even completed the square yet for. So as long as I have an x squared, and let's do a 4y squared. So both variables are squared with the plus sign. Let's do a minus 3x plus maybe a 7y equals 10. So this would be pretty ugly actually, because I gave you an odd number here with the 7. You'd have to factor the 4 out. You'd have to complete a square with this negative 3 here. It'll do an ellipse for you just like that. Okay, so clearly these don't intersect. So you can go from there. Let's say we had a hyperbola then. X squared minus 5y squared plus 10x minus 14y equals 417. Okay, so it throws a hyperbola over here. So I go back to this, and I right-click on it, and I go to the equation. Or if I go to Object Properties, I can come in here, I can edit this a little bit more. So let's say I want to actually move it so it hits that circle. So maybe instead of +5, I've moved this to -5. Okay, that didn't help much at all. So let's do a simple hyperbola, maybe just right at the origin. So x squared minus y squared plus 2y equals 10. There we go. So we could say Earth could be the circle here. One of the shapes on the Meteor thing, if you haven't figured it out, is going to be a parabola. Let's go to this one. It highlights it up here for E, so let's turn that one off. So in this case, we would actually have 4 intersection points. So you'd come up here, intersect 2 objects, click those 2, and it'll actually do it all 4 times for you. So where this is going to be helpful is your calculator is not going to be able to get a picture for you. Doing it by hand is going to be pretty tough, especially with the decimals and graph paper and everything like that. So this is going to confirm the answers you got in the algebraic part. So in this case, so if I come up here and I click on this point C over here, if I did this algebraically, they should hit at -6.91 and 7.23. Okay, and then D over here, whatever. So whatever you get algebraically, you need to have GeoGebra confirm your answers. So everything should match up. You shouldn't get something different. Now what you can do, you can have this. You can go to the snipping tool down here, or a similar program, and you can just grab this picture here. Then you can copy this, you can throw it into a Word file, and you can email that to me as far as your write-up goes, put your name and everything on there. You can print it out and just kind of tape it on your report as well. But something that may also help is including a picture of this so we actually know where those intersections are. So when I look at this, if your math matches up, if they should hit at this point, then you're good to go. So it's a way to check your work. So there's a quick little 10-minute tutorial on how to use Geogebra. Feel free to play around with it. Does lots and lots of cool stuff. You can put sliders in to change the values of different things. You can rotate, reflect, dilate, all kinds of cool stuff. So hope you guys enjoy that.